take a look at the day 24 homework, and this is all about differentiability and continuity. So, we're given a graph and we're asked to identify where the function is continuous but not differentiable. So, in class, we talked about two instances when that happens. So, we're either looking for a vertical tangent or we're looking for a sharp turn. So where on this graph do you see a vertical tangent or a sharp turn? And you're giving it by the value of x here. So I see one right here. I see a sharp turn at x equals 2. And we need to give a reason. So f of x, oh, sorry, we're h of x here. H of x is continuous at x equals 2, but not differentiable because there is a sharp turn. So realize in this assignment, yes, we are talking about continuous and differentiable, but we're also working on that explanation that AP requires. So when I actually write out the statements here, they're intended for you to kind of model that that here's what seeing and this is why, because explaining your reasoning. That's a really key thing to doing well on the AP free response sections. Okay, number 2 then says, hey, let's write an equation for h of x and then show that it's continuous, but show it's continuous. And then in number 3, we're going to show that it's not differentiable. So let's begin by writing a piecewise function for h of x. Now, the first piece is pretty easy because we see that it's a line. Let's try to calculate the slope. I'm going to start here with this point. And it looks like we go down 1, right 2. That means I've got a slope of negative 1/2. Think down 1, right 2. So I've got negative 1/2 x plus, and then my y-intercept for this piece is at 2. Think of the y equals mx plus b there that I'm using. And this piece begins when x is negative 6. And it ends when x is 2. So good practice there with writing the equation for piecewise. Now your second piece is a parabola. Looks like it has a vertex at 4, 5, and it turns upside down. So I know that that's going to be negative x minus 4 squared plus 5. If you want to refresh your memory, remember that you've got vertex form of a parabola. That's where I got that format from because the vertex was at 4 and 5. The negative in front means it just turned the parabola upside down. And that happens between 2 and 6. Now, I probably should not have an equal to on one of them, so we'll take it off of that one. Now, in order to show that it is continuous, we have to show that the function exists. So we see that at h of 2, we do get a y value of 1. And then we have to show that the limits from both sides are equal. So I'm going to do the limit as x approaches 2 from the left. We'll do that from the first piece. And I need to show that that limit is equal to the limit as x approaches 2 from the right. And we'll do that from the second piece. Now let's plug in 2 on both of these and see what we get. I get negative 1/2 times 2 plus 2. And I get negative 2 minus 4 squared plus 5. So negative 1/2 times 2 gives me 1. 1 plus 2 gives me 1. Then I've got 2 minus 4, which is negative 2, squared gives me positive 4, but I'm going to put a negative on it. And so I've got negative 4 plus 5 will give me 1. And that's how I've shown that it is continuous. Let's continue on with number 3 here. We're asked to show analytically by equation that it is not differentiable. So now that we have an equation for the piecewise, let's take the derivative of it. So the derivative of negative 1/2 x plus 2 is negative 1/2. That's going to go from negative 6 to 2. And remember, as we discussed in class, I'm intentionally leaving off that equal sign. Then I'm going to do the derivative of the second piece. So chain rule, I'm going to bring the power of 2 in front. And that's going to go from 2 to 6. Just like we did with the continuity, we've got to show that both sides of this derivative coming into 2 are equal. So we need the derivative from the left. To equal the derivative from the right. Okay, so the derivative from the left is pretty easy because it's just negative 1/2. And the derivative from the right, we would plug in 2. And you can see I get negative 1/2 equals, and then 2 minus 4 is negative 2 times negative 2 gives me 4. Those are not equal, therefore I am not differentiable. Okay, good problem coming up next in number 4. We're asked to find the equation of the tangent line of p of x if p of x is defined as the square root of h of x. All right, so let's see. I'm going to go ahead and rewrite this as h of x to the 1/2. And let's get the derivative so that we can find the slope. So I've got p prime of x equals 1/2 times h of x to the negative 1/2 times h prime of x. Think about your chain rule there. And then let's plug in 3 for each of these x's here. Now remember, when we are looking for h of 3, that's a y value. When we are looking for h prime of 3, that's a slope. So let's take a look at h of 3. Now remember, back here in part 2, we wrote an equation for h of x. So I'm just going to plug it in. H of 3 would be in the second piece here. I would do 3 minus 4, which is negative 1. I would square it, which would give me positive 1. Then I'm going to put a negative on it, which gives me negative 1 plus 5. That's 4. So I've got 1/2 times 4 to the negative 1/2 times, now h prime of 3, again in part 3, we found the derivative. So h prime of 3 would be from the second piece. 3 minus 4 would be negative 1 times 2 would be, I'm sorry, 3 minus 4 would be negative 1 times negative 2 would be positive 2. So let's see what this gives me. I've got 2 on top, I've got 2 on the bottom, and I've got 4 to the 1/2 on the bottom. So the square root of 4 is 2. 2 times 2 is 4. So I've got 2/4, which is 1/2. So I know my slope is going to be 1/2. Now let's find the point. So we need the point at x equals 3. Well, I'm going to put that into my function p of x. Now, h of x, h of 3, we already found was 4. So I've got square root of 4, which is 2. So I've got a point at 3, 2. Now I've got a slope and a point. I can write the equation for the tangent line. There we go. All right. So hopefully we're doing good there. Be sure and put some comments down below if there's something you're unsure about or you want me to go back over one step there. Okay, let's keep going. Let's look at problem number 5. Now, in this one, I like it because it comes in a chart. We haven't done a whole lot of chart ones where we have to draw. So let's take it a little bit at a time. We're told that we have a function that we don't have, it's continuous, so we don't have any holes, we don't have any asymptotes there. From -4 to 5, we have all these descriptors, and then we want to answer these questions. Okay, so let's sketch a graph. The first thing I sketch is all of these points. Okay, so let's start with -4, -5. That would be here. Then I've got -2, -4. Then I've got -1, -2, 0, 1, 1, -1, 3, -2, and 5, 0. Okay, now look at your intervals then. It says from -4 to 0, from this point to this point, that whole section there, increasing and concave up. So from here to here, we are increasing, which means my y values are going up, and I'm concave up. Now remember, concave up looks very similar to a parabola turning up. Now look at your next section. From 0 to 3, from here to here, we are decreasing and concave up. Means my y values are going down, but I'm still going to look like a parabola turning up. Just for that section. Then the last section from 3 to 5, from here to here, we are increasing and concave up. My y values are going up. I look like a parabola turning up. There is my graph. Notice how I read all of that information from the chart. I plot all the points first. Then I read the details about going up and my shape. Do I look like a parabola turning up? Do I look like a parabola turning down? Okay, number 6 then. Estimate h prime of -2. So this one, remember, estimate does not have to be 100% perfect, meaning you're not calculating. So we're going to estimate, right? We might estimate my slope to be between these 2 points. So I could say that h prime of -2 is about, okay? And if I can't do the derivative, can't do it exactly, then I have to get the slope a different way. So I'm going to do it as h of -5 minus h of negative, oh, forgive me, h of -4, excuse me, minus h of -1 over -4 minus -1. You may be saying, well, where'd you get that from? Think about algebra slope. Y2 minus y1 over x2 minus x1. Now, h of -4, we were told, is -5. H of -1 would be -2 over -4 plus 1. Now go ahead and do a little bit of cleanup here. I get approximately 1. The question says, does this support the claim that h is increasing on this interval? Yes. H of x is increasing on the interval -4 is less than x is less than 0 because h prime of -2 is positive. So remember, if we're asking if the function's increasing, we're asking is the derivative positive there? All right. Now look at 7. There are 3 values in the domain of h at which h is not differentiable. Not differentiable. What are these 3 values? Well, I think the easy one is going to be the one where the sharp turn is at, right? X equals 0 because there is a sharp turn. I will throw out another word. Cusp is another way to say this turn there. Now, where are the other two that it's not differentiable? These are not the ones we now normally think of, and they are at the endpoints. So we get x equals -4 and x equals 5. And the reason h of x is not differentiable at these points is because h of x is not continuous there. Think about why it wouldn't be continuous there. It would not be continuous there because the limit from both sides does not exist because we don't have one side of the limits. All right. Our last question for this particular graph is, what intervals is h prime positive? Notice I changed that inequality to words. On what interval is h prime positive? Well, I know h prime is positive when the function is increasing. So where is my function increasing? You can read this from the graph or you can read this from the chart. You're told that the function is increasing here and here. So that gives me my intervals. Let's say it because I got to give a reason. I'm going to go ahead and put it in a sentence. H of x is increasing on -4 is less than x is less than 0, and 3 is less than x is less than 5 because, oh, sorry, I said it backwards, didn't I? Let's say it like this. H prime of x is greater than 0 on those intervals because h of x is increasing. Yeah. So many times we say it the reverse, but I want to make sure that we are saying it the correct way here. So, yes, h prime of x is greater than 0 on these intervals because h is increasing. Okay, just a few more to go with this section of homework. We're almost there. So, number 9 says, at what values of x will the graph have a slope of 1? This is really asking you, and I'll reword it here, where is f prime equal to 1? That's really what that question is asking you. So can you find f prime? Can you set it equal to 1 and solve? Absolutely, we can do that. Let's go ahead and find the derivative first. So the derivative of 2e to the 2x, think of chain rule. So you've got 2e to the 2x times the derivative of the inside. The derivative of 2x would be 2. And then minus the derivative of 3x would be 3. Okay, so we're going to set that equal to 1, and I'm going to clean up all in the same step. Okay, next, let's go ahead and solve for x. I'm going to add the 3 to both sides, and then I'm going to divide by 4. Now, in order to get the x out of the exponent, I'm going to have to take the logarithm of the natural log of both sides. When I do that, this problem becomes a whole lot simpler, right? ln of 1, that's 0. Ln of e, those cancel out, leaving me 2x. So I come out with a pretty easy equation that x is 0. All right, take a look at number 9 then. The graph here is parallel to the normal line. Parallel meaning they have the same slope, right? So let's see if we can find the slope here. Now, you may be able to look at it and tell the slope, and that would be totally fine. Others of you may want to go ahead and get it into slope-intercept form, right? Then I'm going to divide each term by -2, which gives me a 1/2 here. So remember, this is my normal line. So the slope of the normal line is 1/2. So what's the slope of the tangent line? Remember, they're perpendicular, so we're going to flip it and change the sign. Well, if the slope of the tangent line is -2, that tells me what the derivative equals. So I know then the derivative equals -2. Okay, last one here. And this one, remember, we talked about in class was the one we see the most like AP exam. We're given a function defined as a piecewise. We're asking if it is continuous at 1, what's the relationship between A and B? So to be continuous, your function has to exist. It does. We can plug in 1 here. And the limit from both sides has to be equal. So I'm going to do the limit as x approaches 1 from the left. We'll use the first piece to do that. And then the limit as x approaches 1 from the right. We'll use the second piece. Now we get to substitute 1. 3 minus 1 will give me 2. And then very easily with x being 1, I've got a plus b. There's my relationship between a and b. All right, now B says, okay, now that you've found this, let's find the exact values of A and B if we know they're continuous and F is differentiable. So let's go ahead and take the derivative of the piecewise. That first piece, my derivative is going to be 1. And my second piece, I'm going to get 2ax plus b. And remember, in order to be differentiable at 1, my pieces from both sides, my derivatives from both sides have to be equal. So from the left, my derivative is 1. And from the right, if x is 1, I get 2a plus b. Now, notice I've got 2 equations I can solve together. I'm probably going to do elimination. Let's do 2 equals a plus b, and -1 equals 2a plus b. The reason I'm going to do elimination because I can very easily go through here, change all the signs in the second equation so that we can solve. 2 plus 1 is 3. A plus -2a is -a, and the b's cancel. A then is 3. Now that I know what A is, I can definitely substitute it here to solve for B, and B becomes -1. I hope that helps with this homework here. If you have any questions, be sure and put them in the comments below. I would be happy to help. Thanks.